Hello guys, my name is Langson. I'm sophomore year student of Paragon International University and I'm majoring in civil engineering. Today we are going to talk about the Shards, the skyscraper which is located at London, United Kingdom. And this topic was assigned by our engineering dynamic instructor, Mr. Meng Liang Lai. And here is our content. Firstly, we are going to discuss about the Shards background, the overview of the building. Secondly, we are going to talk about the designs and concept of the building. And third, how the wind load affect the skyscraper. And fourth, how we will talk about the concept and solution to the problem. And fifth, we will discuss about the shards, how the shard approach to the problem. And lastly is the reference of the research. Let's talk about the shards background. The shards is located at London, UK. It's colloquial name for the London Bridge Tower. It is essentially a pyramid of glass that stands at the southern terminus of London Bridge with a completion date of 2012. At that time, it has already been recognized as the tallest building in the European Union with 310 meters tall, and we can say it is 1016 feet. The term the shard came about due to the semblance of the building to a shard of glass stepping out of the ground. The shard, the iconic tower, had redefined the London skyline and it's already an international symbol for London. A mixed-use verticality offers more than 50,000 square meters of office space on 25 floors, 3 floors of restaurants, and a 17-story hotel, and 13 floors of apartment and a triple height viewing gallery. And here is the diagrams showing how each part of the shards work, the function of each part. And moving on to the design part. The shard was designed by the famed architect Renzo Piano in conjunction with Broadway Malien. Here is the pictures of the famed architect Renzo Piano. He is an Italian architect best known for his high-tech public spaces, particularly his design. The shard was developed by the Stella Property Group on behalf and jointly owned by Stella Property and the State of Qatar. And the shard is managed by Real Estate Management Limited on behalf of the owner. The shard designed to use specialized windows with a specific glaze that reflect light in a distinctive way. The glaze would reflect the different intensity of light in ways that would change the appearance of the building during different seasons or times of day. And moving on to the wind load and skyscraper. Wind is one of the most important factors that architects and engineers have to consider when designing tall buildings. Wind can cause a bunch of issues for the building, such as broken windows, structural damage, and discomfort for the people. And today, skinny skyscraper has to deal with a particular wind phenomenon called vortex shading. This is principally due to impact that wind forces known as wind loads. The first problem that began to arise was increased wind velocity at street level. This was principally caused by the street canyon phenomenon and the fact that sees large buildings redirect wind down their facades which effectively act like canyon wall and funnel it along streets at much higher velocities than in low-rise suburban areas. This process, much like water flowing down the stream, acts differently on obstacle depending on how streamlined they are. In this case of this building, their sheer block walls created a bluff obstacle that wind had to flow around. As strong winds move around the structures, area of low pressure emerged on the opposite side of them, creating suction forces that pull at the buildings. As the wind speed increases, so does the intensity of the back and forth movement, and it created a sway. And the building also has its own natural sway frequency, and when that match with the frequency of the vortex shading, it creates a dramatic spike in the intensity of swaying. But there are different methods that architect has an arsenal of tricks to reduce the movement, and which we, we can see in the dot line. And moving on to concept and solutions, there are five methods to reduce wind load. The first and by far simplest way to reduce the impact of the high winds on a tall building is fix an approach called the tapering. The designer makes the building skinnier as it gets taller in order to reduce the surface area where the wind is stronger. And it was used in the to build it was used to build the shards and the Willis Tower in Chicago. And another effective solution to the problem is the method called corner softening. We can see sharp edges smooth off a structure to make it more aerodynamic, or small cutouts created on the edge of structure to scramble prevailing winds and reduce the strength of the vortices they create. And the method is applied to the Taipei 101. And creating a twist in a building form can also reduce the impact of vortex shading. With every floor offset to the last, the number of loft areas across these structures is considerably reduced, minimizing or in some cases completely eliminating the location where vortices can fall. Perhaps the most breathtaking example of these techniques can be seen in China Mega Tall Shanghai Tower, which tames the wind and rises to become the world's second tallest building by elegantly twisting throughout its 632-meter height. This twisting method helped to reduce wind load by 24% and saving the developer 58 million in structural material. And the next option is very simple. We can just open it up with the hose. Kingdom Center do in the Saudi Arabia do this method with a single gap up top, allowing the wind to pass right through where it's blowing the strongest. And another method is called damping. Dampers are the mechanism designed to absorb energy from buildings' movement, counteracting the effect of the wind. These incredibly heavy instruments are suspended often on the upper levels of the skyscraper and sway as the buildings move, counteracting motion and creating a more stable environment for those inside. And it has been used in the Taipei 101 called tone mass damper. And this is the Sharp's approach to the wind load problem. And we are going to talk about the tapering method. The Sharp building form is essentially a slender pyramid, but rather than having four similar faces, the external envelope comprises 18 separate shards. The shard is a narrow pyramid, which is 309.6 meters high, with sides sloping at 6 degrees. We all know that the higher up we build, the stronger the wind force gets. So, the designer make the building become skinnier as it gets taller to reduce the surface area where the wind is stronger. Tapering a building as it rises is an effective solution to break up the uniformity that causes vortex shading. Its taper shape works hand in hand with the concept of a multifunctional vertical. The replacement have reduced the building's total embodied energy and provided acoustic separation and structural damping against wind loading. All in all, with the help of this measured solution, in the end, these are the aerodynamic improvement was an incredibly stable skyscraper and also a unique shape which is resist the vortex shading. And it is the picture sketched by hand, as you can see. Its taper shape can help to reduce the wind load because as the building becomes skinnier, it gets taller, it can reduce the surface area where the wind is stronger. And lastly is the reference. And that's all for my presentation. Thank you for attention, and I hope you guys can learn something this from this from this presentation. And if you have any sorry guys, if you have any question, you can comment that in the comment section below. And thank you.